far, I will explain about the introduction. The leaching low-pressure methanol process developed by a leaching oil gas chemist GmbH is a technology for synthesizing methanol using a various feedstocks. The process involves stasis gas generation, methanostasis, and distillation. Leaching has improved catalysis to exchange activity and stability, reducing by-product formation, design element like an advanced inlet design, flex tube outlet, and the insulation efficiency. Key process features include oxygen-bound gas reforming, two-step methanostasis, and acid gas composition adjustment. They are forming configuration depend on a feedstock composition, while a leaching mega methanol incorporate autothermal catalytic reforming for a specific gas.
Hi, my name is Daripada. My mention number is AA220275. As the block flow diagram, first we do desulfurization, and then we do saturation. Next is pre-reforming, following by autothermal reforming. After that, we do methanol synthesis, and last but not least, we do methanol distillation.
Sekarang saya akan menerangkan slide berkenaan dengan instrument simbol and process flow diagram of PFD in methanol. Ini merupakan standard industrial instrument simbol yang kami gunakan untuk mereka satu proses flow diagram berdasarkan standard piawaian yang telah ditetapkan oleh ISO atau dikenali sebagai International Standard Organization. Terdapat 6 simbol yang telah kami gunakan untuk mereka proses flow diagram. Yang pertama adalah horizontal vessel, kedua adalah exchanger, ketiga adalah column, keempat adalah pump, kelima adalah heat exchanger, dan keenam adalah air cooler. Ini merupakan gambar rajah untuk proses flow diagram bagi bahan metanol yang telah kami reka di dalam AutoCAD. Ini merupakan final design untuk proses flow diagram of metanol yang telah kami reka supaya dapat melihat proses flow diagram dan juga simbol-simbolnya dengan jelas. Kalau dilihat di dalam diagram ini, terdapat crude metanol yang memasuki di dalam proses flow diagram dan juga fuel gas, pure metanol dan juga proses water yang akan keluar daripada proses ini yang dikenali sebagai output. Dari segi simbol, terdapat 3 kolom, 4 vessel, 8 exchanger, 5 pump dan juga 1 heat cooler yang berperanan dalam melengkapkan proses flow diagram untuk bahan metanol.
Assalamualaikum, my name is Muhammad Aidil Mukis bin Sa'adi Anwar. My metric number is AA222070, and today I'm going to explain about process description. Desulfurization catalyst activity can be affected in the presence of sulfur in the feedstock gas. To protect catalyst, the feed must be desulfurized first. Desulfurization operates at a level of approximately 350 to 380 degrees C in the reactor. Zinc oxide is added to the feedstock along with hydrogen sulfide to produce material as in the equation below. H2S plus ZNO produce ZNS plus H2O. If the feedstock contains organic sulfur material, it must be hydrogenate before desulfurization first with a liter methanol gas rich in hydrogen on cobalt molybdenum catalyst. Saturation. Feed gas into the saturator for saturation with a large supply of water required for forming reaction. After the process of condensation and distillation, hot water is passed over the saturator. This water will cause a downward movement with the water below moving upwards and cooling it before being fed back into the saturator. Pre-reforming. If the feedstock contains fraction of higher hydrocarbons, the steam reformer catalyst can be affected by carbon depositing owing to cracking reaction when operate at low steam-carbon ratio. This should be avoided by pre-reforming the feedstock in a pre-reformer. The conversion of higher hydrocarbons in an adiabatic reactor produce a gas rich in methane and hydrogen that is perfectly suitable for further steam reforming. The fixed bed type pre-reformer is arranged between the process feed superheater and the steam reformer. The desulfurized feedstock with process steam added is routed through the catalyst bed, where almost all higher hydrocarbon and a small percentage of the methanes are reformed with steam according to the following equation. CO plus 3H2 produce CH4 plus H2O. Pre-reformed gas is produced in 380 to 480 degrees C. Performed gas contain only a few parts per million higher hydrocarbon than methanes and allows for a reduced steam to carbon ratio. This can reduce the size of the steam reformer significantly. Autothermal reforming. Pure autothermal reforming can be applied for syngas production whenever light natural gas is available as feedstock to the process. Reformer outlet temperature are typically in the range of 950 to 1050 degrees C. The synthesis gas is compressed to the pressure required for methanol synthesis in a single casing synthesis gas compressor with integrated recycle stage. Gas flow and temperature profiles are stimulated with the objective of design burning and reactor as an integrated unit. Autothermal process produce the heat required for gasification through partial combustion of the feed gas to be converted in the reactor. Oxygen is usually added for this purpose. Suitable feedstock for autothermal catalyte reforming like natural gases or steam reformed gases with a higher residual methane content. Methanol synthesis. Methanol is synthesized from hydrogen, carbon monoxide and carbon dioxide in the presence of a highly selective copper-based catalyst. The principal synthesis reactions are as follows. CO plus 2H2 produce CH3OH and CO2 plus 3H2 produce CH3OH plus H2O. These reactions are highly exothermic and the heat of reaction must be removed promptly from its source. Efficient conversion in the methanol synthesis unit is essential to low-cost methanol production. In addition, optimal use of the reaction heat offers cost advantages and energy saving for the overall plant. Nowadays, two types of catalytic fixed bed reactor are used in industry are steam raising reactor and gas cooled reactor. Methanol distillation. The raw methanol produced in the methanol synthesis unit contains water, dissolved gases, and a quantity of undesired but unavoidable byproducts that have either lower or higher boiling point than methanol. The purpose of distillation unit is to remove these impurities in order to achieve the desired methanol purity specification. This is accomplished in the following process step: degassing, removal of low boiling byproducts, removal of high boiling byproducts. Dissolved gases are driven out of the raw methanol simply by flashing it at a low pressure into the expansion gas vessel. Removal of light ends and remaining dissolved gases is carried out in a light ends column. Finally, the methanol is separated from the heavy ends in pure methanol distillation section consisting of 1 or 2 columns. The split of the refining column into 2 columns allow for very high single train capacities. Methanol purity remains unaffected, whereas the single train capacity, consumption of steam and investment costs depend on the distillation concept. Conclusion: the process in the production of methanol must go through various methods and processes in its production. This production plant involves the synthesis of methanol, a chemical raw material that is important in its production. It must go through many plant units in its production, such as desulfurization, saturation, pre-reforming, autothermal reforming, methanol synthesis, and methanol distillation. Each of these units has its own function in the production of methanol. These units are also interconnected with each other in a process flow diagram for process plant. The result of this production will form pure methanol that can be used for other industries. That's all. Thank you from our group.